So today I'll be talking about some of the characteristics of the sound system of Nafsan, also known as South Efate, which is a Southern Oceanic language of Vanuatu, spoken by around 6,000 people on the island of Efate in 3 villages. You can see on the map just here, Erakor, Pango and Eratap. And the current study, what we're presenting today, is actually part of a wider project looking at various aspects of the sound system, and in particular looking at the phonetic characteristics of a range of different speech sounds. And a lot of this research is based on data collected in Erakor, which you can see here is a very challenging place to work. The consonant inventory of Nafsan includes 4 contrastive places of articulation for stops and nasals, and the places of articulation include labial-velar consonants, so a labial-velar stop and a labial-velar nasal, and that's of particular interest today. And there's no voicing distinction in the stop system. One of the reasons why labial-velar consonants are of particular interest is because typologically they're complex sounds. They are sounds that are produced with overlapping, though not necessarily simultaneous gestures, with a labial closure as well as a velar closure. And they seem to be realised in quite different ways in different languages around the world, even very closely related languages. They're not that common across the world's languages in general, but there are particular regions where they are found quite commonly. So in particular, Central and West Africa, labial-velar consonants are very common in various different language families there. And also in some parts of the Pacific, including some regions of PNG, some languages in the Solomons, Vanuatu, and as far as I understand, also New Caledonia, although these have featured much less prominently in cross-linguistic discussions of labial-velar consonants. Within Vanuatu, there are various types of consonants that could be described as labial-velar, so involving both a labial and a velar closure that overlap. So these might include doubly articulated stops and nasals, so b or m, or bilabial and velar stops that have a secondary articulation, which is rounding or labialization, so something more like b or mo. Or a combination of those, so doubly articulated stops that also have secondary articulation rounding, so something like w or w, where you have a combination of those. And of course the labial-velar glide is labial-velar as well, and it's sometimes worth remembering that that's also a complex sound. Sometimes it's not grouped with these, but often you do see patterns where it fits with those in various ways, historically and synchronically. So a series of labial-velar consonants has been reconstructed for Proto-Oceanic, and there's been various bits of discussion around this, but only some Oceanic languages retain labial-velar consonants in the regions that I mentioned just before. And the origin of these sounds has been debated, and I won't go into that today. There's been plenty of other discussion about it, but there are questions about whether these sounds relate to a Papuan linguistic influence, whether they arose in certain phonological environments related to specific vowel contexts. The historical and comparative research that has been done suggests that there's been a lot of phonological instability for these consonants, a lot of changes over time that are not always very predictable and not always very neat compared to some of the other more regular sound correspondences. And there are also questions about the phonetic characteristics of these sounds, both historically and synchronically. There's information that could be gained from more detailed understanding of how these are actually produced, because sometimes all we have is an orthographic representation for languages with limited records. It's hard to know what that sound really is. There have been some distributional patterns observed for labial-velar consonants in Oceanic languages. For example, that they tend to occur in initial positions, word or syllable initially. They often occur before open vowels, and they rarely occur adjacent to back-rounded vowels. And some of these generalizations are also noted in cross-linguistic discussions, which actually are mainly focused on African languages. Although I haven't seen any discussion of distributional patterns in African languages that relate to vowel environments, so that's one possible difference. So in many African languages, they will also occur word or syllable initially or morpheme initially. There's also been comments that they tend to occur in roots rather than affixes, and also that they rarely contrast with sequences of labial and velar stops, or velar and labial stops rather. And it's also been noted there's been more phonetic research done on labial-velar consonants in that region in Central and West Africa, that there's an enormous amount of variation in how these sounds are produced, even in different dialects of the same language. So, I mean, we know that even in any language, a plain bilabial stop is going to be different in one language compared to another. We use the same IPA symbol, but the actual phonetics of that sound is always going to be slightly different from language to language, but that's even more the case for these complex labial-velar articulations, it seems. Nafsan shows exceptions to all of those distributional patterns that have been noted in cross-linguistic discussions. It's not the only language of Vanuatu that shows some of those exceptions, but it does show exceptions for all of them, which makes it a sort of interesting case study for some of the things we're interested in. So we presented some phonotactic data at the Vanuatu Languages Conference last year, showing that labial velars do occur word finally, although they're not that frequent in word final position, and in fact they're less frequent consonants overall. So this is looking at data from both the lexical database and the corpus. They do occur adjacent to rounded vowels, preceding and following rounded vowels, although again not that frequently. And they do contrast with sequences of velar and labial stops or velar and labial nasals. And at the end of that talk, we presented some very exploratory phonetic data just based on a little bit of few tokens for one speaker, which suggested there might be a few different phonetic correlates of labial velars compared to other stops, but these might be a little bit different depending on what word position they occur in. So we wanted to look at that in a little bit more detail. So the two main questions for today are what cues distinguish the four plosives from one another, so the bilabial, alveolar, velar, and then the labial velar, with the labial velar being of particular interest, and then how are those labial velar stops realised in different word positions. So we'll present a little bit of data based on 4 participants, so 2 men and 2 women from Erikor village on the island of Efate in Vanuatu. There's also some more data for 2 others which is not yet included. And we put together a word list that had 97 items, including these consonants in different positions. So as word initial onsets in monosyllabic words, so in a word like gaf, as word medial onsets in disyllabic words, so in a word like kakas, and as word final codas in monosyllabic words in a word like lak. And the stops are all adjacent to open vowels, so we can also look at what the formant trajectories look like adjacent to these consonants. And they were recorded with these speakers in a medial frame, which also had an open vowel either side of the target word. So the medial frame was essentially, I say X on Sunday, which is like some of these frames that phoneticians like to use, a little bit silly, but there's not that many words in Nafsan that start with an A that can occur in that sort of position. So for example, would be anakaf aliatab. And the speakers produced this utterance 5 times in response to a spoken prompt from me. And for these 4 speakers so far, we have close to 2,000 tokens. There's some other stuff that's been built into the data set too that we won't talk about today. And so these recordings were orthographically transcribed first in Prat and then converted to Sampa, which is the machine-readable phonetic alphabet, in order to facilitate automatic segmentation using MAUS, the Munich Automatic Segmentation System. They have a language-independent model that has worked quite well for our data on Nafsan and some other languages that don't have a dedicated language model. This is all manually checked afterwards in case there need to be any corrections of the boundaries, so we're segmenting the individual speech sounds, but especially because some of the questions we have relate to duration, we really want to check how accurate those are. These Prat text grids and WAV files are then turned into a hierarchical database using the EMU speech database system. And then additional labelling was done to mark the voice onset time, which I'll talk about in a little bit. And then the analyses are performed using R, and then some statistical tests using linear mixed effects models, and taking into account the effects of individual speakers and the different individual words. And just for interest, this is the database system here where, for example, it shows some of the tiers. So it's got the word here. It has the syllable, which is labelled W and S for weak and strong, and this relates to prosodic analyses we've been doing in other studies. And then it's got all the segments marked up here. But what's really useful for our purposes is that these are hierarchically linked, which allows me to then say, okay, I really want to look at the trajectory of the formants in any long vowel in the first syllable of a 2-syllable word that has, this consonant in it. So I can do very specific queries to get out exactly what I want in order to make these kinds of comparisons. And so going on to some of the results. The first thing I was interested in was closure duration, so how long the articulators are held together based on the labelling of the stop in the spectrogram. And what we can see is that the labial velar stops are longer than the other stops in all word positions. So this first plot here, hopefully the colours are okay. So the labial velars are in this sort of purpley colour on all of these plots. And you can see that they're longer, and this is a significantly longer difference by about 25 to 37 milliseconds, which is reasonably long. You would expect that to be something that someone can hear. But there aren't any differences between the other stops in duration. So these are word initial onsets, so at the start of a monosyllabic word. If we look at the word medial onsets in those disyllabic words, again, the labial velars are longer, even a little bit more long than in the word initial onset, so 45 to 55 milliseconds now, quite consistently, and no differences between the other stops in that position. And in codas again, the labial velar stops are longer than all of the other stops. There are some small differences between the bilabial, alveolar and velar, but they're in the range of about 5 milliseconds, so very small but slight differences in that word position. Although one thing we'll have to take into account is that occasionally there's a little bit of pausing after the target word here, which we'll have to factor in some later analyses too. So the next series of plots is looking at voice onset time, and what this is essentially looking at how long it is from when the articulators open until voicing begins in a vowel that follows. So if you have a consonant which we might think of as being phonemically voiced, and there's some voicing being produced during the actual closure of the consonant, then the voicing starts before the release of the articulators. But if the articulators release and there's a lot of aspiration, it's only after that aspiration that the voicing starts for the following vowel. So essentially that black line down the middle, the 0 line, that's when the articulators open. And so the labial velars, the values are plotted down here in the purple as well. And what we can see is that for the labial velar consonants in word initial syllable onsets, they have very consistently a bit of pre-voicing. So none of these are produced with what we call positive VOT. The pre-voicing is about 26 milliseconds, and it's quite a narrow range. It's pretty systematic across the 4 speakers here. There are also some small differences for the bilabial, the alveolar, and the velar stops, but again, much smaller, so about 5 milliseconds in the differences here. So you might say that the velar stop here is very weakly aspirated if we compare the values here to what we see for languages like English, where you have a difference between what we orthographically and also phonemically write as B and P, but which is actually a difference between unaspirated and aspirated. So we could say the velar stops are weakly aspirated, but in general, not much aspiration and a bit of pre-voicing here. If we look at the word medial onsets, similar pattern, a little bit more variation. The pre-voicing is still very apparent for these labial velar stops, about 23 milliseconds here, so it's similar to what we see in the word initial position. Not always. Occasionally there is a little bit of positive VOT or a little bit of release time after the articulators before the voicing starts, and it doesn't start during the closure of the consonant. And in those cases, the values that we get, they're more like what we see for the bilabial stop. So we get just a few there. And sometimes for the velar stop, there's a little bit of pre-voicing, but these are all examples where the speaker was actually leniting the stop to a fricative, so it's really more to do with a little bit of frication and voicing as well. So there are also here differences between the bilabial, alveolar and velar stops, again about 5 milliseconds in the statistical results, but again weak aspiration for the velar stop in that position. So now looking at the formant trajectories, so these stops were all recorded with the same open vowel either side, although it was sometimes long vowels and sometimes short vowels. And I'll play you some examples here perhaps before I talk through it. So we're looking at as the articulators open. If you have a little bit of a listen.
Bak. Kak. Bar.
So those word initial onsets. And what we see is that in this position, the labial velar stop, the purple line here, is more like the bilabial stop on the release than like the velar stop. So essentially a b is more like a p as you open the articulators than a k. As the articulators close, as we go into those word medial onsets, the labial velar stop is more like a velar stop. So here's the bilabial in the purple, in the pink, and then the labial velar is here overlapping with the velar. So I'll play these ones as well.
Napas. Gagas. Nakbak.
So more similarity between the velar and the labial velar when you're going into the consonant closure. And I'm just looking at F2 here, sorry, I should have mentioned that more explicitly. That's really where we see the difference between these consonants. As a coda, so looking at those word final codas, there are differences between the bilabial, the velar, and the labial velar, and the labial velar is really somewhere in between. So I'll play this one as well. So this is as the articulators close for a coda.
Nap. Mak. Sap.
That's kind of the example that I've picked here. And these are from a word list. I should mention these aren't from the experimental materials because I'm trying to give you a sense of the kind of canonical pronunciation of these. But what you get is that some speakers, there's a bit of individual variation here. For some speakers, there are indications that there is a bit more merging of the labial velar and the bilabial in this position. But it seems to be something that people do a little bit differently. So overall, essentially the labial velars end up somewhere between. But this might be something that explains partly why a lot of languages prefer having labial velars in this position because they can be difficult to perceptually distinguish from bilabials. So we can see, as we expect, because this has previously been described from the language, that there's a clear contrast between labial velar stops and other stops, bilabial, alveolar and velar in Nafsan. But the cues to the contrast might depend a little bit on the context. The formant measures confirm impressions that at least when the labial velar is in onset position, it seems like the velar closure occurs before the bilabial. So they don't totally overlap. You have some timing differences where you start with the velar closure and then afterwards the lips round and close. But in codas, there might be a little bit more overlap there, and there may be some indications that there's even a merger in progress for those sounds in that position, although it's too early to say that, but there's definitely some more overlap. One thing we'll have to do is pick apart the patterns between the short and the long vowels here because the dynamics might look a little bit different. There's no indication of rounding for the labial velar stop, so it doesn't look like it's a wa compared to a ba, which is interesting because a lot of the languages in Vanuatu are at least orthographically written as though there is rounding afterwards, but I think this is something that's interesting to check because it might relate to the distributional restrictions on whether or not these labial velar consonants can or can't occur adjacent to rounded vowels. If you need to hear that rounding for the consonant to distinguish the consonant, it would be very hard to hear if you also have a rounded vowel afterwards, whereas if that rounding is not part of the consonant, you can probably freely combine them with rounded vowels. But this is something that remains to be tested, and I'd be very interested to hear from other people's language data what kinds of distributional patterns you see, because I've only kind of found sort of corpus data for a few languages where I've been able to check that. So I'd like to hear more about that. The consistent duration differences for the labial velar stops are probably quite perceptible, especially in that word medial position where 45 to 55 milliseconds, that's really quite long. But it's worth noting that the labial velar stop is still shorter than sequences of a velar and labial stop. So I haven't presented that here, but we also have data on that was collected in the same word list here with some other items, and there's still a consistent difference between those. So it doesn't encroach on that other contrast, needing to hear that sequence. The partial voicing of the labial velars can be exploited as an additional cue in Nafsan, perhaps because it doesn't have a phonemic voicing distinction, so you can perhaps use voicing for some more individual consonant differences rather than the systematic voiceless compared to voiced series. And one thing that I think is really interesting is that the amount of pre-voicing, this sort of around 25 milliseconds, is pretty consistent with findings for some African languages in which labial velars are often described as being a little bit imploded. And that is perceptually what it seems a little bit like in Nafsan, although we'll add some additional measures to check that. So a little bit of implosion is when the air is being drawn in and the larynx is lowering rather than being pushed out at the release of that consonant. As noted elsewhere in the cross-linguistic discussions focusing on African languages, the phonotactics and the production of labial velars probably does depend on language-specific structures, like whether or not you can even have codas in the language. A lot of languages, some languages of Vanuatu are quite happy with coda consonants, others aren't. So if codas aren't possible, of course, the labial velars won't occur as codas. And a more detailed understanding of the characteristics of oceanic labial velars would perhaps further the understanding of their evolution and variation within the region and within oceanic languages, but also inform phonetic typology more broadly, given that most of the discussion is focused really on African languages rather than those from the Pacific region. So I'd just like to conclude by thanking all the Nafsan speakers who've contributed to this work, especially Marinette Kalparam, Grey Kaltapau, Lionel Emil and Michael Joseph, and others whose participation earlier has led up to this work. Thank you.
Thank you, Rosey. Yes. So I'm Alex Francois, and I work in the north of Vanuatu, where there's lots of those complex consonants with also which are also rounded. So b and b in what is actually an extinct language now, but I have recordings, and w, and they fit lots of things that you're saying in different ways. So in some languages you find them in codas, so you tap. And interesting, I'd like to see phonetic, analysis of this, because I have lots of data, which I can show you. But I've, to have a look at what exactly is going on. One thing interesting also in historical terms of sound change and all is that a typical thing will be the interference between a rounded vowel and the consonant, but the interesting thing, it goes both ways. Mm-hmm. So if you have the etymon bongi, which is the night, bongi, you have traces, of reflexes of a change from bo to mbo, and then bo, and then bo. So the northern languages have bung or bung. But if you go even more north, which is hiu, what used to be kwang is now kung. So you have the unrounded, so the O, the rounded vowel, contributed to rounding the consonant first, making it a labial velar, and then unrounding it to the point that B has come to K now. So it's quite a spectacular change, which I show to my students sometimes, how a B can yield a K. And this is consistent with what you said.
Yeah, I think it's really fascinating. We've been just sort of kind of in a very preliminary way comparing some of the records for different languages of Efate, and even within a small region you see so many of those exact same patterns where things have perhaps rounded and then unrounded, or even very closely related varieties have got a lot of differences in just some particular segments. So yeah.
Maybe just the question that comes with this is, would you say it's more frequent to have the vowel contributing to rounding a consonant or to unrounding it, or in your view?
I mean, I don't, my main area of research isn't historical linguistics, so I wouldn't feel that well placed to comment on kind of cross-linguistic patterns, but what I do think is really interesting is that those kinds of patterns don't seem to have really come up much in the discussion of African languages at all, which is where most of the discussion of labial velars in sort of phonetic typological terms has taken place. So I don't know if it's something that's a bit more regional here, or whether, it's more to do with where they come from and how the changes have played out. But I mean, we know that lots of sound changes of various sorts can go both ways. This might be one where it's particularly striking, but there are other things where things can be lenited and then fortition can happen later. So it's not always a one-way process anyway. Yeah.
Any question for Rosey?
For the phonetics, you mentioned that open vowels are particularly frequent. Now in the southern Vanuatu, in the southern Amban languages, you don't find in this context, but you also don't find a velar, labial velar, only labial labial velars. And I'm wondering whether this is some connection there, that R is maybe not that typical after Ho, more, and so on.
Yeah, I mean, I don't know yet, but I think there's some very interesting patterns that could be discovered there across Vanuatu, because I think it might play out a little bit differently in language to language. In Nafsan, the open vowel is far more frequent than the other vowels in general when we've sort of looked at the frequency in the lexical database and in the corpus. And there's also a distinction between the short and the long open vowel, and if we're looking at long vowels, it's also the long open vowel that occurs more than the other long vowels. So it might also just be to do with that being a good location for hosting contrast if it occurs a lot, and you can easily perceive labial velar adjacent to it, but I don't know. So it would be nice sort of as a separate thing to see more frequency data of, different phonemic segments and phonotactic combinations in different languages, because I think that would play into some of these questions here as well. Yeah.
D'autres questions pour Rosey? One question.
I was interested in what you said about the historical background. I have to admit I have problems with the Donoghue and Denham paper which you quoted, because they pick on things from all over the Papuan region. But I've been working recently on Papuan languages of the Madang province of Papua New Guinea, and it seems to me that the patterns there, they're definitely not co-articulated in the, what we're getting is KW, PW and so on. But the patterns there in relation to the vowels that can follow them are exactly the ones that you describe. And it's at least a tempting inference that this is where Proto-Oceanic originally got these forms from, because I think they are quite clearly reconstructible a long way back. But as soon as you go outside the Oceanic subgroup, you don't find them at all. So I think the inference is a reasonable one, but it's there's nothing probative about it.
No, thanks. I was, after the Vanuatu Languages Conference last year, some of us heading back to Australia on different flights were stuck at the airport for kind of a solid 6 hours or something like that. And Nick Evans was there, who's doing a lot of work in Southern New Guinea, and had, so we were looking through his different lexical databases and found a lot of those same correspondences there. It was a good time to check it. I think Manfred was there too. We were having a bit of a look. So I think there's some interesting patterns that are not just within Vanuatu about that, yeah.